Okay, I've worked on this some more. It was floating on pure magnetic bearings and spinning pretty good in the last video I did a couple weeks ago. But you know, it wasn't very stable. I could just like bump it like this, you know, just go like that, and it would drop. The rotor would drop down, and I could see it's just not going to be something that can go 1200 RPM. So I kind of sold out to reality, and I put a skateboard bearing in up here, and I have a timing wheel, little timing disc with 14 small magnets here, because my plan is I'm going to pulse this 14 times a revolution. And I made some motor coils. Here's the core. I used to use these in my Konehead motors. This elevator bolt would be against another elevator bolt like this. And if this is the rotor, this would be the stator, and I would pulse it, boom, around north-north. And then I had another elevator bolt here. And so the rotor was this, with steel elevator bolts with ferrite cores, tubes slipped over them. You need to shave down right here a bit on these things. You can get these at hardware stores. There's a little square piece of metal right there. So you just got to kind of file that down smooth, and now you can get the ferrite butted up against the steel face there. So what I've done is I've turned this around backwards. I don't want this steel against these neodymiums, so it's actually pulled back a little ways, that far away from the end of the ferrite. So this is going to go on there like that, and then I file at about 15 degrees, as you can see here. And here's the motor coil. This is just the motor coil. I want to have two motor coils at 180 degrees on this. These are wound with Litz wire, and they're directionally wound. You can see where it's pulled back. You wind from the back to the front, bend the wire 90 degrees, pull it back, and then continue the next layer in the same winding direction. When you get to the front again, you pull it back straight, do it again, and so this is a directional wind with Litz wire of the motor coil. The generator coil, you can see, will be covering all this ferrite all the way to the back, kind of a backstop, I call this, back there. And I go over about half of the motor coil too. And so every time this motor coil pulses, it's going to induce a lot of power into this core. And I don't know if you call it power, but it's going to induce a lot of power into these generator winds. And not only that, but the neodymium magnets going past this ferrite core is going to be working like a generator too, generator effect. So that's going to be my generator coil, is behind the motor coil. And I wound these tri-filer, 3 lengths of 165 feet, and it's 28 gauge wire, pretty thin wire. So I should be making a lot of voltage, not so many amps. And hopefully at 1200 RPM, there should be no Lenz braking. That's what I'm planning on. So I want this to be at go 1200 RPM. See this white, this is the angle that this will be firing at, right there. And so I'll be drilling a hole through this plywood wall over here to mount my motor coils. About right here, so. And then I want to put another one on the other side at 180 degrees. And that's the plan. And so I have a skateboard bearing up here. And a magnetic bearing supporting it still. So it's kind of hybrid. Sorry I sold out, but I can see myself spending months trying to get a really reliable magnetic bearing thing going. I did do a lot of work these past few weeks trying different backing magnets, or stop magnets I call them, you know, that keep it elevated. And I finally have a really strong magnet down here that keeps it up in the air, plus the it wants to be biased to go up too, so there's fairly strong force shoving it up in the air. And then I adjusted everything so it's not so strong, it kind of wants to drop. That's how I had it before when I had magnetic bearings up here, where it just about wants to drop, but it doesn't. And that's where I had that nice smooth spinning with it all on magnetic bearings that I took a video of last time. But if you just hit the thing, you just go like this, not even that hard, just like that, it goes poof. And so, and I tried really big magnets, did a lot, but so I just said I'm just going to put in a skateboard bearing up here. I want to get this going. And so I'm going to be putting a motor coil with a big generator coil behind it over here, and another one over here, 180 off, and I'll be hooking these in series, this motor coil to this motor coil I plan on. So it'll be pretty high impedance, so the draw will be very low. And I'll be putting a little Hall effect up here, as I normally do. 14 times, 14 of these here. And so 14 times the revolution, it'll pulse the magnet, and the magnet in between will not be pulsed, and then it'll pulse. And these are north, south, north, south, north, south. So my plan is on that every other pulse in between that, like you pulse it here, this magnet will be the time when you pulse out. And if the timing is right, the pulse out should give it a little oomph to the rotation too. So there should be a little speed up when you pulse out the cap that'll be storing the flyback back EMF energy. I know there's a difference between flyback and back EMF, but I think there's a combination of two of them happening at once when it really is going good in the output, but that's another story. So here's how it spins now. Very nice and smooth. The skateboard bearing's just a cheap skateboard steel skateboard bearing. Later on, maybe I'll put in a ceramic one. It spins very smooth. So the weight of this rotor is supported by this lower one. And the only friction is the top skateboard bearing. And sorry I sold out, but like I said, I can see myself spending months perfecting some sort of magnetic bearing thing. David Parfit has a patent on a magnetic permanent magnet thrust bearing. Be nice to put one of those in maybe in the future. And so I'm hoping we'll be getting no Lenz effect at 1200 RPM with the tri-filers as David Bowling has in his Black Beauty motor generator. So these would be tri-filer series 18. And my hopes are the power induced in this, it not only is from the motor coil pulsing, will induce all behind it, all of it behind. Also the ferrite core with a magnet sweep past it will be creating power too. And then I'll be stuffing the flyback also into a capacitor. All of this into a capacitor. And then the capacitor can fire the opposite coil. And then same thing happens over here. This fires the opposite coil. I might not have it 180 off, but rather one coil is right on the magnet and the other coil will be firing right in between. I'm not sure if I'm going to do that or not. I can make it a test and do it both ways. I like having the coils in series. So, Hall effect up here. I can adjust the timing by moving the Hall effect a little each way, same as I've been doing on my other stuff. And then a MOSFET pulsing the motor coil. And this is where I'm at now. I'm thinking hopefully 12 volt input would have about 20 milliamps. I'm guessing that's what I'll have. And then what we get from this is going to kind of depend on Lenz law. If there is no Lenz law, or there is. Because if you pull out power and you get Lenz law, everything you get is just erased because it takes more power to make the power that you make. So I need to have this going 1200 RPM. I don't know if I can do it 12 volts, 20 milliamps at 1200 RPM, but we'll see. Maybe it's going to take 100 milliamps to go that fast. I'm thinking 1200 RPM because Whoopi has a video at 2100 RPM with 16 magnets. He gets no Lenz. If you go under that or above it, you do get a Lenz, like a 100 or 200 RPM window you can be within. And then there's that David Parfit. I just looked at his videos and put them up on EV Gray. And with 22 magnets at 1800 RPM, he gets no Lenz. So there's two people. And then David Bowling with his tri-filer series 18 coils at 2800 with 16 coils, no, with 12 coils. With 12 coils at 2800, he gets no Lenz. David Parfit, with his 22 magnets, has a 1.8 ohm load, which is pretty low impedance. And David Bowling has light bulbs as his load, incandescent light bulbs. So it's the RPM window to hit. Whoopi had LEDs as his load. So the load is also a factor if you're going to get no Lenz or not. And the RPM window, where you kind of outrun the generator coil as it becomes an electromagnet, it takes a little bit of time for it to have enough force to drag itself backwards, drag the rotor backwards, force the rotor backwards from Lenz law, Lenz reaction. And that time period, if you can make it so that occurs on the upcoming magnet, or perhaps the back edge of the induced magnet, then you're actually going to get a speed up. You still have a Lenz reaction, but it occurs at advantageous time where it's going to not pull the rotor backwards, but push it forward. And that's what I'm looking for with this. And I apologize, I don't have it pure magnetic rotor, but I want to get moving on this thing. So that is my latest video. Thank you for watching.